Very good morning. This is Balaji, Assistant Professor, Department of Mechatronics Engineering, SNS College of Technology. So, on today we are going to discuss about what is integrated automation and then distributed control system and then evaluation of DCS and type of architecture which is available in DCS. Okay. So, what is integrated automation? In industries, we have to automate the all kind of manufacturing process by respective applications like PLC and then embedded system. Those kind of softwares are available to control some kind of automation. So the automation which is used for to manufacture the all kind of product by using without manual application. Okay, so that is what integrated automation. In integrated automation we'll be using the application softwares, communication protocols, and then some kind of actuators. The actuators may be like single acting cylinders, double acting cylinders, DC motors, stepper motors. So we have to control those kind of actuators by using those some kind of applications like PLCs and SCADAs. Okay, and then we have to communicate. We have to make the communication between the all those softwares and then actuator by using some communication protocols. So which we have seen in our last classes like communication protocols, ART protocols, OSI models, those kind of protocols we have seen in our last class. Okay, so in this video we are going to discuss about DC, okay, which is meter distributed control systems. Okay, next slide. So in our last class we have discussed about what is SCADA and then SCADA architecture and then what are the terminologies available in SCADA architecture. So SCADA is one of the automation application which is used for to control, to monitor, to diagnose the all automation problems. For the application we can use the SCADA system. Okay, so we have four kind of questions available. So what is the advantage of SCADA for the industry operators? So in the let me answer for all those questions. Okay, so the advantage when you are using the SCADA system, we expecting the many kind of accuracy level of output. Okay, and then we can control the dispatches, and then we can control the many kind of automation application by using the SCADA system, and then we can monitor, we can store the data, and then by using stored data we can rectify the all kind of industry specific problems. Okay, and then what is the use of function communication link in SCADA system? So in the communication system in SCADA we can communicate the data between the field devices and then our software applications. Okay, software application. So for the application we can use some communication systems in SCADA system. So why do companies are using SCADA system? For increasing the productivity and reliability. That is what a very important one thing. Okay, for the increase the productivity and reliability, we can use the companies are using the SCADA system. Okay, and then what is an HMI? So HMI, which is a human machine interface, by using the HMI we can enter the data by using manually. Okay, if you need to control any kind of works by using some manual application while you are using the SCADA system, we can use the HMI. HMI is one of the inbuilt system which is available in our SCADA system. Okay, so you can see some SCADA system components which is available in the screen. Okay, so we have some main SCADA operator, and then we have some remote terminal units, and it may be like any kind of PLC system, and then we have some output devices. It may be any kind of sensors or any kind of actuators. Okay, so by fetching the data from our actuating devices to the PLCs, or which means the RTU, we can control the all kind of entire operation by commanding from the SCADA systems. Okay, so the data from the RTU and PLC which is go to our SCADA system, by checking all those kind of data, we can give a command to our RTU and PLC. By using the RTU and PLC command, the all kind of actuator will be working on it. Okay, and then alarm monitoring. So alarm monitoring is used to control the disorders, and then we can specific parameter control. We can use the alarm monitoring systems. Okay, so next slide. So in this DCS system, we can discuss by using design thinking applications. Okay, so what is design thinking application? In design thinking, we'll be having 5 stages available. One is the empathy, and then define, and then ideate, and then prototype and test. Okay, so in empathy, so what is meant by empathy? What the use of the topic? Why need to study? We have to study this topic. So that is what the empathy. Okay, and then in the industry standard, why need to use the DCS? Okay, that is what industry pain points. Okay, define. So what are the challenges that people are facing while using the without automated application, without DCS? Okay, that is what the core challenges. Okay, ideal in those problems, how we can rectify the in single solution. That is what we'll be using the ideate, and then prototype will be develop the architecture by using the components by using our ideate. Okay, and then we'll be seeing about introduction to DCS, and then empathy and define, maybe need of need of our DCS, and then in ideate we are using the see about our DCS architecture. In prototype we can see our timeline of the DCS evaluation. So next slide. Click on it. Okay, thank you. So let's explore what is DCS. Okay, so DCS is a computerized system which is used to control the all automation operation by using the single device. So in our last class we have discussed about SCADA system. So what is the difference between SCADA system, DCS system? So SCADA, we have many kind of softwares, and then many kind of output devices, and then many kind of input devices. So those devices different one we have to interface all those kind of devices. But in DCS we have a separate special purpose application one, okay, which is used for if you need to control any drilling machine, you can get the DCS drilling machine control process. Okay, so for the application you can get the DCS. Okay, and then in the same DCS we have a same DCS automation application, the same DCS communication protocols, same DCS output devices. Okay, that is what different between SCADA system. In SCADA system we'll be having different kind of PLCs, different kind of automation applications, different kind of terminal units, different kind of output devices, and different kind of input devices. Okay, but in SCADA we'll be having specific mission. In the specific mission in inbuildly they'll be having separate automation applications and separate output devices available in our DCS. Okay, for that application we can use the DCS. So you can see the system, the computerized control system of the managing the complex industrial problems. We can use this in DCS for the networked control applications by using some communication protocols. So that is what we have discussed about in DCS. Okay, so in power plants, in any kind of industries, in DCS system, people will be having those kind of setup in our industry. Okay, so we'll be having a separate input devices, separate automation applications, separate output devices. Okay, so next slide. So why DCS is matter in our digital world? So what is the need of DCS? What is the need of DCS? Why need to use the DCS? Okay, so you can see in the screen so many kind of cabling, and then many kind of wiring devices, and then many kind of slow responses, and many kind of manual monitoring works, and then many kind of high cost and then safety compliance. We'll be using the DCS instead of traditional operators, and then controllers, and then output devices. We can use the DCS because DCS it is having a inbuilt automation applications, inbuilt input output devices, inbuilt cabling devices, for the inbuilt communication devices. So those kind of devices are available in same system. Okay, so we can neglect the our monitoring, slow monitoring, and then manual monitoring, and then response times. We can increase the response time easily, and then we can monitor easily in our all those kind of parameters, and then we can neglect the wiring, and then we can rectify we can reduce our cost systems, and then we can rectify our safety compliance. Okay, so for those application we can use the DCS. Okay, next slide. So define. Okay, what are the steps to rectify the all those kind of problems. So we have many kind of steps available now. Okay, like in problem statement, we might create a control system that distribute the intelligence to eliminate the all those kind of problems. Okay, so that intelligence system is called our DCS system. Okay, DCS system. So it should be reliability, it should be flexibility, it should be efficiency one. Okay, so reliability, no central failure points available in your DCS system, and then flexibility, there is no it should be flexibility in model integration with the sensor and actuators. Okay, see, we have a real-time data processing predictive actions available. Okay, so for that application we can use the DCS. So remaining thing we can see in our next video.